All right, this is lesson 9.2, solving quadratic equations by graphing. Hey, we spent a whole unit graphing quadratics, didn't we? Yeah, we did. That was a whole unit, chapter 8, graphing quadratics. So this should sound very familiar. Now remember, when you are asked to solve the equation, you are asked to find the zeros. Find the zeros. Another way of saying that is you are asked to find where the graph crosses the x-axis. All right, where the graph crosses the x-axis. Those are the x-intercepts. Remember, the x-intercepts. We're going to look at several different ways of solving quadratics. This is just one of them, remember? All right, this is just one of them. So we are going to graph to find where our function crosses the x-axis. The first step is to write the related function, okay? So we have been given x squared plus 2x equals 3. We need to write the function. So what that means is I'm going to take my x squared minus 2 plus 2x, equals 3. I'm going to subtract 3 on both sides so that I can get an equals 0 here. I've got x squared plus 2x minus 3 equals 0. To write the function, all I'm going to do is replace my 0 with y. All right? That will turn it into a function. So x squared plus 2x minus 3 equals y. I'm just replacing the 0 with y. So our function is y equals x squared plus 2x minus 3. That is our function. The second step, we need to graph. Well, in order to graph, I have to know some things. So I'm going to scoot this up. One of the things I need to know is the axis of symmetry. So our a value, who's hanging out with our x squared, he's a ninja, is 1. Our b value is a positive 2, and our c value is a negative 3. The axis of symmetry, remember, is x equals negative b divided by 2a. So I'm going to plug in my values. That means I've got a negative 2 over 2 times 1. Well, wait a second. That's negative 2 over 2. So that means x equals negative 1 is my axis of symmetry. X equals negative 1. Now that I know my axis of symmetry, I can find my vertex. I'm going to take my function here, and I'm going to plug in my negative 1 everywhere I see x to find my vertex. So y equals negative 1 squared plus 2 times negative 1 minus 3. Well, negative 1 squared is just 1, plus 2 times negative 1 is negative 2 minus 3. Well, 1 plus negative 2 is negative 1. Negative 1 minus 3 is negative 4. So that means my vertex is at negative 1, negative 4. I know because a is positive, it's a positive 1, then I have an upward opening quadratic, right? So let's go over here. I am going to count by 2s, 2, 4, 6, 2, 4, 6. So really every box is worth 1. I just don't like crowding my graph with too many numbers. Oh, and I need negatives on some of those. My bad. There we go. So I know that my axis of symmetry is at x equals negative 1. So it's right there. That's my axis of symmetry. I know my vertex is at negative 1, negative 4. So it's right there. And I know my y-intercept as well. Remember, your y-intercept has to do with c. So my y-intercept is at 0, negative 3. So it's right here. And I can mirror that point. 0, negative 3. There we go. I can mirror that point across our axis of symmetry. Now, here's the bad thing. I don't actually touch the x-axis. I don't touch the x-axis. So I haven't found my zeros yet. I have not solved the equation. So next thing I'm going to do is a table. All right, the next thing I'm going to do is a table. I know I'm going to touch where x is bigger than 0, and I know I'm going to touch where x is less than negative 2. It's going to be somewhere past that point, right? Because I can connect these with a nice little curve. I know it's not going to connect in between them, so it'll have to be greater than 0 or less than negative 2. So I'm going to do a little table here with my x and my y values. It's helpful to have a calculator, but you don't have to. I'm going to do -1. So when x is -1, I know I get -4, right? When x is 0, I know I get -3. What about when x is 1? Well, when x is 1, I get 1 squared plus 2 minus 3. Well, 1 plus 2 is 3 minus 3. Hey, that gets me 0. So that is our first x-intercept, is 1, 0. So where x equals 1 is our first. Now here's the cool thing. If I know that I have a point here, I can take any point and mirror it across my axis of symmetry. So rather than continue my table in the other direction, I know that this is 2 away from the axis of symmetry, which means I need to go 2 in the other direction. So one of my zeros is at x equals 1, and the other 0 is going to be at x equals, read your graph, -3. All right, x equals -3. We should do a check on those. I am running out of space, however, so hopefully you believe me and you say, cool, that will work. And it really will. Let's take a look at another example. I'm turning the page over. All right, our next one, we have x squared minus 8x equals 16. Remember, our first step is to write the function. So we need the function. So that means I've got x squared minus 8x equals -16. I'm going to add 16 on both sides. So we get x squared minus 8x plus 16 equals 0. I change my 0 into a y. So now we have x squared minus 8x plus 16. Then I need to go to graph it. So my function is now x squared minus 8x plus 16. So when I graph it, I find my a value, it's 1, my b value is -8, and my c value is positive 16. Our axis of symmetry is x equals -b divided by 2a. So x equals -8 divided by 2 times 1. So that gets us, -8 is a positive 8, 2 times 1 is a 2, well 8 divided by 2 is really 4. So x equals 4. Let's plug that in to find our vertex. So I have y equals x squared minus 8x plus 16. So we get 4 squared minus 8 times 4 plus 16. Well, that's 16 minus 8 times 4 is 32 plus 16. 16 minus 32 is -16. -16 plus 16 is 0. So my point is 4, 0. Wait a second. Let's plot that and take a look. I've got a 2, 4, and a 6. 2, 4, and a 6. If I take a look at this, that point lies right here, right? That is the point. And I know a is positive, so it's a smiley face, so it's going to look something like that. That means that we cross at only one point, right? X equals 4 is the only solution, right? It's the only solution. We only cross at that one point. All right, let's take a look at our next example. Oops, there we go. Let's take a look at our next example. So for this one, we're going to find the related function. I'm going to add x squared on both sides, mostly because I don't like dealing with a negative x squared. That's just annoying, right? So we get 0 equals x squared plus 2x plus 4. I change my 0 into a y, so we have y equals x squared plus 2x plus 4. And now I need a graph. Well, what's my a value? He's ninja, 1. B has a value of 2, and C has a value of 4. Hey, C means we know our y-intercept right off the bat. It's going to be at 0, 4. Let's find our axis of symmetry. X equals -b divided by 2a. So x equals -2 divided by 2 times 1. That means we get negative 2 over 2, so x equals negative 1. Now I need to plug that in to find my vertex. Our equation is y equals x squared plus 2x plus 4. So we plug in negative 1 everywhere we see an x. So we have 1 minus 2 plus 4. 1 minus 2 is negative 1, plus 4 is a 3. So y equals 3. So my vertex point is then negative 1, 3. So my axis of symmetry, I'm going to draw on here at my negative 1 position, because I'm going to count by 2's. And then I know that I have an intercept at 0, 4. I can mirror that point across my axis of symmetry now, right? And my vertex is at negative 1, 3. Oh, wait a second. When I sketch this out, does my graph cross the x-axis? No. It does not cross the x-axis. So this means we have no solution. There is no solution. It never crosses the x-axis, so there's no solution. All right. Email me with questions. Let's try another example problem together, and then I'm going to have you guys practice for a while on your own. I think we'll do 2 together, actually. All right, our next one, we have x squared plus 7x equals negative 6. Equals negative 6. So we are going to add 6 on both sides. We get x squared plus 7x plus 6 equals 0. I change my 0 into a y, so we have x squared plus 7x plus 6 equals y. Or if I rewrite that with my y first, y equals x squared plus 7x plus 6. When I go to graph this, my a value is 1, my b value is 7, my c value is 6. Hey, that means I know my y-intercept. My y-intercept is going to be 0, 6. Let's find our axis of symmetry. X equals negative b divided by 2a. We plug in 7 for our b, so we get negative 7. We plug in 1 for our a, so 2 times 1. That means we have x equals negative 7 halves. I highly encourage you to keep it as a fraction, but I understand some of you really, really hate fractions. So if you really want to use decimal, go for it. I'm keeping it as a fraction. We need to plug this in to find our vertex. So we have y equals x squared plus 7x plus 6. I am plugging in y equals negative 7 halves squared plus 7 times negative 7 halves plus 6. It's going to get a little tricky with those fractions, but this is good fun, good practice. So with our negative 7 halves squared, that's like having negative 7 halves times negative 7 halves. So I have a positive 7 times 7 for our numerator is 49. 2 times 2 for our denominator is 4. Then I've got 7 over 1, really, right? Times negative 7 halves. So that gets me a negative 7 times 7 is 49. 1 times 2 is 2. And I have a plus 6 hanging out here. When I add these together, I have to double this, right? I have to double this. So this becomes 98 force. And then when I add them together, I get, plus my 6 there, negative 25 force, which is the same as negative 6.25. So if you like the decimal version, this is what you get. If you stick with my fraction, this is what you get. Next thing we need to do is write that as a coordinate point. So our coordinate point would then be negative 3.5, or negative 7 halves, and negative 6.25, which would be negative 25 force. Those are our two. I'll plot this one. It's easier to graph, right? So that's our vertex, negative 3.5, negative 6.25. So on my graph up here, each box is worth 1. except for going vertically, sorry. Going vertically is worth 2. So 2, 4, 6, 8. Negative 2, negative 4, negative 6, negative 8. So I am at negative 3.5, so right there, and negative 6.25. So just a little bit below that negative 6, just a little bit. This is also where my axis of symmetry is. It's right here, right? And I know I have a y-intercept at 0, 6. When I reflected across, I went 3.5. So if I double that, I get to 7. So here's the bad thing. I can graph this, right? But I cross somewhere in here, and I don't know exactly where. I don't. We skipped the x-axis. So the x-axis was not where our y-intercept was, and it's also not where our vertex is. We skipped it. So we need to do a table. So I'm going to start with my x and my y. It's helpful to have a calculator for this, right? X, my y. I know that if I have negative 7 halves, I get negative 25 fourths, right? And I know that it'll be somewhere between, if I look at my graph, it's going to be between somewhere in negative 3.5 and 0. All right, somewhere between there. So let's just try negative 3. Well, negative 3 squared is 9. Negative 3 times 7 is negative 21. 9 plus negative 21 is, oh, brain blank, 12. Negative 12 plus 6 is a negative 6. Well, that didn't get to the x-axis either, right? Because I need 0 here. So let's go with negative 2. Well, negative 2 squared is a positive 4. Positive 4 plus negative 2 times 7, which is negative 14. 4 plus negative 14 is negative 10. Negative 10 plus 6 is a negative 4. That's not 0 either. Let's try negative 1. All right, negative 1 squared is 1. Plus 7 times negative 1 is negative 7. Well, 1 plus negative 7 is negative 6. Plus 6 is 0. This is our first one. So our first 0 is where x equals negative 1. That's our first 0. So right here is our first 0. My sketch of my graph was a little off. So I will try and make that, there we go, better. This point is 2.5 away from our axis of symmetry. So I can reflect it, and I get my second 0, which is at x equals negative 6. You should check both of those, all right? You should check both of those. So when we do our check, so twisted. Sorry about that, guys. When we do our check, we have x squared plus 7x equals negative 6. I'm going to plug in our negative 1. So negative 1 squared plus 7 times negative 1 equals negative 6. That's 1 minus 7 equals negative 6. Negative 6 does indeed equal negative 6. The other one we want to try is negative 6. So x squared plus 7x equals negative 6. We would get negative 6 squared plus 7 times negative 6 equals negative 6. Well, this would be 36 minus 42 equals negative 6. Yes, negative 6 equals negative 6. So our two checks work, which means our two zeros are indeed x equals negative 1 and x equals negative 6. What if we're just given a graph, though? Let's just think about that. What if we're given a graph? Now, this is called a trinomial. It's something you'll see a lot of when you get into Algebra 2. I wanted us to be able to look at it, though, because you can actually look at a graph that is given to you and see what the zeros are. We touch the x-axis right here. If we read the graph, that is at x equals negative 1. We touch it right here as well. That's at x equals, it's right where the y-axis is, so that's a 0. And we touch it right here, which is between 1 and 3, so that's at x equals 2. Now, if you want to, you could solve this algebraically even. I'm going to show you that because we did talk about factoring. If you know that you have y, which is the same as f of x, so y equals x minus 2, and then x squared plus x. We know we can factor this. They have a greatest common factor. So I'm just going to leave my x minus 2 to hang out, and I know I'm going to have two parentheses here. Their greatest common factor is x, and what's left over is x plus 1. So then I can set each of these equal to 0. We get x minus 2 equals 0, x equals 0, and x plus 1 equals 0. I add 2 on both sides, so we get x equals 2. He's just an x equals 0, and then I subtract 1 on both sides, so I get an x equals negative 1. I can check those, or you can look at me and go, hey, look at that. There's two different ways. You can look at the graph or solve it algebraically. Isn't that awesome? All right, I want you to try the next 5 on your own. I'm going to go over the answers. So start with this one. See if you can find the zeros. Just read the graph. Find the zeros. All right, visually, if you just looked at the graph, you would have found x equals negative 4, x equals negative 2, and x equals negative 1. Isn't that awesome? Here's the algebra for it in case you care. You get the same answers though. All right, I'm going to turn the page over for you guys to try a couple more. So our next one is x squared plus 7x equals negative 10. Try it out, see what you get. All right, for our next one, you should have gotten an x equals negative 5 and an x equals negative 2. We actually skipped from our vertex to the y-intercept, so you had to plug it into a table to try it out and find it. All right, so here's kind of all the summarized information at the bottom while graphing it. All right, let's try another one. Our next one is x squared plus 36 equals 12x. Try it out, see what you get. You should have gotten y equals x squared minus 12x plus 36 for your equation. When you go to graph that, your y-intercept is at 0, 36. Your axis of symmetry is at 6, and when you plug in that 6 to find your vertex, you get a y of 0. So it only crosses once right there at the x-axis. So x equals 6 is your final answer. There's only one. X equals 6 is your final answer. All right, the next example, we've got an x squared plus 10x equals negative 25. Try it out, see what you get. You should have gotten y equals x squared plus 10x plus 25. Your axis of symmetry is at x equals negative 5. When you plug that in for your vertex, you get a y of 0. This is another one where it only crosses once. There's only one 0 at x equals negative 5. All right, two more examples. Our next one is 2x plus 5 equals negative x squared. When you go to graph it, we get y equals x squared plus 2x plus 5. And then we have an axis of symmetry at negative 1. Our vertex is at the point negative 1, 4. Wait a second. When I go to graph that, I can see that it never crosses the x-axis. So this has no zeros. There is no solution, is another way of saying it. No solution. The last ones we're going to talk about are another set of look at the graph. Look at the graph, see where it crosses. For our top one here, you should have gotten an x equals negative 3, x equals negative 2, 1, and 2. Again, I have it algebraically here as well. There's a lot of factoring going on. A lot of factoring. The last one, if you just looked at it, you would have seen it only crosses twice, even though it's got kind of 3 sort of humps, if that makes sense, or bumps, however you want to call those. You should have gotten x equals negative 1 and x equals 2. All right, x equals 1 and x equals 2. Those are your answers. And algebraically, if you did it, just a quick note here, x squared cannot equal a negative number because a negative times a negative is always a positive. So there's nothing to the second power that ever makes a negative, right? So only two answers. Email me with questions. Email me with questions. Skills practice is posted.